Hello friends, myself R.D. Mahajan presenting my new series of videos on beta and gamma function. These beta and gamma functions are very important tools for the evaluation of a definite integral. In this video, I will discuss about a gamma function, its definition and properties. Therefore, we define that gamma function as the integral of the form integration from 0 to infinity e raised to minus x into x raised to n minus 1 with respect to x with the condition that n is greater than 0, means n must be positive, which is a function of n is called as gamma function. Therefore, and it is denoted as, this is the symbol for gamma function, gamma of n, and we define it as gamma of n is equals to integration from 0 to infinity of e raised to minus x, x raised to n minus 1 with respect to x with the condition n greater than 0. If we have this type of definite integral, then it is called as gamma function. Condition is n must be positive. Then after defining that gamma function, we try to see the properties of gamma function. The first property, value of gamma 1 is 1. Then second, gamma of n plus 1, there are two values. The first one is n gamma n, or another value is n factorial if that n is positive integer. Whenever that n is positive integer, we consider the value of that gamma n plus 1 as n factorial. And the last one, gamma 1 by 2, is the root pi. Therefore, these are the three important properties of gamma function. We are applying this, or we are using this in the chapter of Laplace transform. Then we try to see some simple examples based on that properties for gamma function. The first one, find the value of gamma 7. Whenever we have to find the value of any gamma, we rewrite it in the form of n plus 1. Therefore, that 7 I can write down as 6 plus 1, where the value of n is 6 here, which is positive integer, and as it is positive integer, its value is 6 factorial. Okay. Second, find the value of gamma 5. That gamma 5 we can rewrite as n plus 1 form, in the n plus 1 form. Therefore, it is 4 plus 1, gamma of 4 plus 1, and here the value of n is 4, positive integer, and as it is positive integer, its value is 4 factorial, n factorial, as per the property. Then third, find the value of gamma 3 by 2. That gamma 3 by 2 we have to rewrite in the form of n plus 1. Therefore, it is 1 by 2 plus 1. I can rewrite that 3 by 2 as 1 by 2 plus 1, where that n is 1 by 2, not positive integer, and as it is not positive integer, we apply that property. Its value of gamma n plus 1, the value of gamma n plus 1 is n gamma n, and therefore here it is 1 by 2 gamma 1 by 2. And then using the property, we know that the value of gamma 1 by 2 is root pi, and therefore it becomes root of pi by 2. Gamma 5 by 2, find the value of gamma 5 by 2. First step, we have to rewrite in the form of n plus 1. That 5 by 2 I can rewrite as 3 by 2 plus 1. Therefore, here n is 3 by 2, not positive integer, and as it is not positive integer, as per the property, its value is n gamma n. Therefore, it is 3 by 2 gamma of 3 by 2. We have to rewrite that gamma 3 by 2 in this form till we get that 1 by 2 term, gamma 1 by 2 term. And therefore, in next step, I can rewrite this 3 by 2 as it is, no change. That gamma 3 by 2 we can write as 1 by 2 plus 1. Then once again applying that property. What is the property I am using? That is gamma n plus 1 is n gamma n or it is n factorial, this property. N factorial when that is positive integer, and therefore here it is not positive integer, that 3 by 2 as it is, no change. N 1 by 2 and gamma 1 by 2, gamma n. Then simplifying it, this becomes 3 by 4, and the value of gamma 1 by 2, is root pi, and therefore it becomes 3 by 4 into root pi is the value of that gamma 5 by 2. One more, find the value of gamma 7 by 2. First we write in the form of n plus 1, therefore it is 5 by 2 plus 1. Then applying this property, as it is not positive integer, we apply this property, its value is n gamma n, and therefore it is 5 by 2 gamma 5 by 2. Next one, it is equals to, that 5 by 2 we write down as 3 by 2 plus 1, therefore out of 5 by 2 as it is. Okay. Next, once again applying the same property, therefore it is equals to 5 by 2, n is here 3 by 2, and gamma 3 by 2. Once again rewriting that 3 by 2 in the form of 1 by 2 plus 1, and therefore we get that value as that 5 by 2, 3 by 2, and this 3 by 2 we can write down as gamma 1 by 2 plus 1, and then applying the same property once again, we get that value as 5 by 2 as it is, no change, 3 by 2 as it is, no change. This gamma n plus 1 is n gamma n, as it is not positive integer, therefore it is 1 by 2 gamma 1 by 2. Therefore that value is 5 3 is 15, 2 to the 4, 4 to the 8, and the value of gamma 1 by 2 is root pi. Therefore, these are the very simple example to know how we can use that properties of gamma function. Remember this type of calculation we have to perform in Laplace transform while obtaining the Laplace transform. Then some problems for the evaluation of the integral. First one, integration from 0 to infinity, e raised to minus x, x raised to 3 with respect to x. And whenever we have to evaluate it, we compare this with that definition form, and therefore I can rewrite this integral as limits are 0 to infinity, same limits. We have the term of e raised to minus x, we keep that as it is, and this x raised to 3 we write in the form of n minus 1, therefore that we can write down as 4 minus 1. N minus 1, 4 minus 1 we get x raised to 3, and then as per definition its value is gamma n, and here n is 4. And then to evaluate the value of gamma 4, we rewrite in the form of n plus 1, therefore it is gamma of 3 plus 1, where n is 3 positive integer, and as it is positive integer, its value is n factorial, therefore value is 4 factorial, and it is 24. Like this, we can take the help of that definition of a gamma function to evaluate such type of definite integral. Evaluate integration from 0 to infinity of e raised to minus x into x raised to 3 by 2 with respect to x, and then once again converting in this form definition of gamma function, I can rewrite this as 0 to infinity, no change. E raised to minus x also I will keep as it is. This x to 3 by 2 we write in the form of n minus 1, and therefore that 3 by 2 we can write down as 5 by 2 minus 1 with respect to x. And as per definition, here n is positive, value of n is 5 by 2, and therefore as per definition it is gamma of n, and therefore it is gamma 5 by 2. And to find the value of gamma 5 by 2, we write in the form of n plus 1. Next step, that 5 by 2 I will write as 3 by 2 plus 1. N is here 3 by 2, not positive integer, and therefore we apply this n gamma n property, and therefore it is 3 by 2 gamma of 3 by 2. We can rewrite that 3 by 2 as it is. 3 by 2 we can write as 1 by 2 plus 1. Okay, and then once again applying the same property, we get that value as gamma n plus 1 is n gamma n, therefore it is 1 by 2 into gamma 1 by 2. And then we continue this step, we repeat that step till we get the gamma 1 by 2 value, or the term of gamma 1 by 2. I can rewrite directly like this, 3 by 2, 1 by 2, gamma 1 by 2. No need to write in this form. Then it is 3 by 2, 1 by 2, and gamma 1 by 2 is root pi. And therefore it becomes 3 by 4 into root pi as the value of that definite integral. Therefore, in this video, I have discussed two important things. The first one is the definition for gamma function, and the second one is the properties. And based upon that properties, I have solved some simple examples. I have discussed some simple examples. In my next video, I will discuss as beta function, its definition and properties. Therefore, if you like my videos, please share it as well as subscribe to my channel to receive notification for my new videos. For that, you have to press the bell icon. Thank you. Thank you for watching.